Our final shape we're going to look at is spheres, and we're going to talk about both surface area and volume. Now, a sphere is a set of all points in space equidistant from a given center. So like a circle, it's all points equidistant, but now we're talking 3 dimensions instead of 2. Now in a sphere, we still have a radius, like a circle, and there is still a center, like a circle. And our most common sphere we know is our own planet. Now, surface area of a sphere is 4 pi r squared, r being the radius. So if we look at our example here, the surface area is 4 pi times 14 squared, or 784 pi centimeters squared. Volume, on the other hand, throws in a fraction. So it's 4/3 pi r cubed. So this is the first time now we have something to the third power. So our volume here is 4/3 pi r cubed. Our radius is still 14. So if we look at this, we take 14 cubed and then take 4/3 of that, and we get 3,658.7 pi centimeters cubed. So on our same spheres, we have a volume in the almost 4,000 or 3,500, and we have, if we go back, we have only a surface area of 784. Obviously, both of them multiplied by pi. So very different in terms of size. So let's look at 2 more examples, finding the surface area and volume of the figure. So in the first one, my radius is 5, so my surface area is 5 squared times 4 times pi, or 100 pi units squared. My second one, I still have a radius of 5, but now I'm cubing it and taking 4/3 of that, giving me 166.7 units cubed. In the second example, they give me a diameter instead of a radius. And that's okay, because we know that the radius is half the diameter. So our radius here is going to be 2. So we have 4 pi of 2 squared, which gives me 16 pi meters squared. And then volume is 4/3 pi r cubed, and 2 cubed is 8, so 4/3 of 8 gives me 10.7 pi meters cubed. So again, notice how the volume is much greater than the surface area. Here's an actual application, and since we talked about the Earth being our most common sphere, let's look at an example. The Earth's equator is about 24,901 miles long. What is the approximate surface area of the Earth? Now I know we could Google this answer, but let's see if we can actually figure it out. Now when we're talking about our equator, that's the line that goes around the middle of our globe. And so the equator actually represents the circumference of a circle. So we need, in order to find the surface area, we know we need the radius. And so to find the radius, we're going to use our circumference formula. Let me say that again. The equator represents the circumference of our Earth, or of a circle. In order to find the surface area, we know we need the radius. So we're going to use our circumference formula to be able to find the radius. So circumference of a circle is 2 pi r. So to find the radius, we're going to divide our number, 24,901, by 2 pi, giving us a radius of 3,963.1 miles. So that's about how long it is from the outside of the Earth to the core of the Earth. Now we can find surface area. So surface area is 4 pi r squared. So we're going to take our radius from our last equation, plug it into our formula, and the surface area of our Earth is 1.97 times 10 to the 8 square miles. Now if we're talking in actual numbers, it's 197 million square miles of surface we have on the Earth. Now we know some of that is covered by water. Actually, a lot of it is covered by water. But think of how much surface area is on our little planet. Alright, now that we've talked about that, your turn to find the surface area and volume of each of these figures. Alright, for the first one, our surface area is going to be 400 pi square inches, and our volume is 1,333.3 pi inches cubed. Check my math, make sure you understand where I got each of these. In the second example, our surface area is 256 pi meters squared, And our volume is 682.7 pi meters cubed. Again, check your math, compare it to mine. Pause the video if you need to, and if you have questions, please bring them into class. And that's it for volume and surface area of spheres. Have a great night.